In this lesson, we are looking at perpendicular lines. Our essential question: what are the key ideas about perpendicular bisectors of a segment? Theorem 3.1. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. If you think about it, when you have a straight line and a line that intersects it, in order for the two angles created by the intersected line to be congruent, there's only one way for that to happen, and that's if you split the angles in half. Linear angles are equal to 180 degrees, so in order for these to be congruent, this has to be 90 degrees and this has to be 90 degrees. The notation for perpendicular is this upside down T, and this is saying that G is perpendicular to H. So know this notation here stands for perpendicular. Theorem 3.2. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. If you have two angles that are in a perpendicular angle, then the sum of this angle plus this angle have to add up to 90 degrees, which makes them complementary. Theorem 3.3. If two lines are perpendicular, then they intersect to form four right angles. Proofs. When writing a reason for a step in a proof, you must use the following information. What are you given? Do you know any definitions that you can use? Any properties that you can use? A postulate that you can use? Or a previously proven theorem? Here's a hint for writing proofs. When you write a complicated proof, it may help to write a plan first. The plan will also help others to understand your proof. Proof of Theorem 3.2. In Theorem 3.2, we said that two sides of two adjacent acute angles are perpendicular, then the two angles are complementary. So we are now going to prove, if we have two angles that make up a perpendicular angle, that the two angles are indeed complementary. Our plan for proof is to use the measure of angle ABC is equal to 90 degrees, and that the measure of angle 1 plus the measure of angle 2 gives us the measure of angle ABC. And we're going to use that to show that angle 1 and angle 2 are complementary. We start with our statement. The first one that we're going to write is our given. We know that the ray BA is perpendicular to ray BC, and that's our given. Because I know that perpendicular rays create 90 degrees, I know that angle ABC is a right angle, and that's using the definition of perpendicular lines. Because I know that right angles are 90 degrees, I can say that the measure of angle ABC is equal to 90 degrees, and that's using the definition of right angles. I also know that the measure of angle 1 plus the measure of angle 2 will give me this entire angle ABC. So I can say that the measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2. That's using the angle addition postulate. Because I know from step 3 that the measure of angle ABC is equal to 90 degrees, I can substitute 90 degrees over here for the measure of angle ABC and say that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. That's using the substitution property. Finally, because I know that if two angles add up to 90 degrees, they are complementary angles, I can say that angle 1 and angle 2 are complementary using the definition of complementary angles. Alright, checkpoint problem number 1. You are to prove Theorem 3.3. In this problem, you are given that J is perpendicular to K and angle 1 and angle 2 are a linear pair. Your goal is to prove that angle 2 is a right angle. Alright, that's it from me. I'll see you all soon.